So here's the second half of the deflection problem. It's actually more like the second 75% of the deflection problem. We've already seen that if we dropped something from a height to z naught, that our deflection due to the Coriolis force, the acceleration of the Coriolis force, was equal to minus 2 omega cross v. And we could integrate that twice, starting with the initial conditions. And here's a picture of what we actually have. So, because I'm going to use this coordinate system repeatedly. This is k hat, y hat is north, and x hat's into the board, and omega is over here. So that's theta. So once and for all, we can see that omega cross k, which will happen repeatedly, omega cross k hat is going to be omega, I'll call it omega naught, sine theta, I hat, into the board, just right hand rule, omega cross k, omega cross k. All right. So we saw that the answer was just dropped, call it just drop. It was equal to 1/3 omega naught sine of theta. And then we have 2 z naught, not the most convenient form for it, but it does make everything related to the data from the initial problem. And this is to the power 1/2. All right. So now the second part of this problem is to send it up and to bring it back down. So we're going to split this into two pieces. So let's look at the Coriolis deflection going up. We start, of course, by writing the accelerator, and I'm not going to label this up and down on the dynamic quantities themselves. I'm just going to put up here. All right, minus 2 omega cross v comes out in this case. What did I do wrong here? Okay, minus 2 omega, it will be minus 2 omega cross, and let's talk about what v is. V going up is going to be v naught minus gt. This v naught is in the z direction, so we throw it up, and it comes back down. Well, it'll come back down later, and this is k hat. And we've already seen that this comes out to be, from the result here, minus 2 omega naught sine theta, v naught minus gt. So the deflection is in the I hat direction, and that, I guess, let's see, if that's north, I guess that's east. Okay, so this is I hat. And we're lucky in this case that x double dot can be integrated directly. Let's just put one more line in here. This is mine, just rewrite that. Minus 2 omega naught sine theta, just to make the connection in your head here. We only have to look along the I hat direction, even though that's vectorial. I can turn it to the scalar analog. So this is then v naught minus gt. So we can have x dot, and here's where you get into trouble if you don't do the initial conditions correctly. So we integrate this once, and we get minus 2 omega naught sine theta. You'll see exactly what I mean by that in a little while. Minus v naught t minus gt squared over 2 plus, and then this would be v naught. If we drop it from rest, v naught at t is equal to 0. That vanishes, that vanishes, that vanishes, and the only way we can balance it is for v naught to be equal to 0. So that gives me x, integrating again, x of t will be equal to minus 2 omega naught. I should have just called this something at the beginning. V naught t squared minus g t cubed, t cubed over 3, this is over 6, plus x naught. And we'll just say that the x naught is right here. We're going to shift this a little bit later, just use our intuition. So I know that at 0, t equals 0, x naught is equal to 0, because this is equal to, because I'm pointing like you can see, this is equal to 0, at t is equal to 0, that's all 0. So we've got, finally, x of t is equal to minus 2 omega naught sine theta. And we'll call the time it takes to get to the top. We're going to use two different ways to get to the top here. To get to the top, here's what I have. So let me write that as v naught capital T minus g capital T cubed over 3, where t is the time it takes to get to the top. Now we have two relationships we can immediately obtain, which is if we drop something or something goes up, doesn't really matter. The up and down is the same for us. So this is to the lowest order approximation, or to the omega level approximation. The time it takes to get up there is essentially the same as the time it takes to drop back, which is 2 z naught over g from 1/2 gt squared is equal to z naught. So that's 1/2. You also have v naught from 1/2 mv squared is mgh, or mg z naught here. 1/2 mv naught squared is equal to mg z naught, masses cancel. This is the well-known v naught is equal to the square root of 2. I should have said g is equal to 1, but I'm a dope. Z naught. The interesting thing you see immediately here is that v naught is one thing I missed when I started working this problem. Could simplify everything by v naught is equal to g. Look at the t over here. If I multiply here by g, right where I'm tapping with that dot, the g squared will come in and I'll get 2. So this is equal to, like a dope, I missed this entirely when I did the first work through it the other day. So that's gt. So these two things are very useful results, because now I'll get x of t up. Now I'll call this up is equal to minus 2 omega naught sine theta. Look how much this cleans up now. So this will be gt cubed here, because v naught is gt. So this will be gt cubed minus g t cubed over, this was over 2 here. Sorry. So this is over 2 divided by 6. So what I'm left here is minus 2 omega naught sine theta. I'll have g. 1/2 minus 1/6 is 3/6 minus 1/6. And that's going to come out to be 2/6, which is 1/3. So I'll bring that out here. And I'm left with, where's t cubed? T is right here. 2g z naught power 3/2. And if you look at up, that's 2 z naught over g. And this is then minus 2/3 omega naught sine theta. The g goes in here. This is g to the power 1, obviously. So what I'll have is 2 z naught. We'll keep that as a cubed. I want to express this in terms of a square root. So I'll call this 2 z naught cubed and put a g inside, because this will then be a 1 square root left over when I bring this in here, g squared over g. So this will come out to be that to the power 1/2. So notice I've got an extra factor of 2 here. So x up is equal to, now what do we call x up? Early 90s or early 80s next generation rap band right after Sugar Hill. It's kind of a non-threatening name, the Sugar Hill Gang, X up. Okay, so this is minus 2 of x drop. So that checks out. I'm going to stop the tape here. We'll do part 2 in a second.